Hi everybody, my name is Ismail Selim. I am actually data scientist at Trinity University. Today I will discuss the paper Temporal Logistic Neural Page Bag of Feature for Financial Time Series Forecasting Limit Order Book Data. This paper just published recently from the group in Finland, Nicholas Basil and the other. Today we will to go too deep in the paper. We try to give some uh, definition for time series. What is the technique available now for forecasting time series? And then in the age of big data, we actually get advantage of big data age tools to have time series forecasting tools. And then we will talk about the concept of bag of features, and then we discuss the architect proposed by the author of the paper for their system for forecasting time series. And then we will discuss the result and the discussion about the result of the paper. Uh, Imagine that all of us, like, the future of stock prices, you can become actually wealthy. There is many in all the days two ways to forecasting the future, diviner versus science, and I think Eddie Murphy was in the side of science, which more trustable because we know what exactly is the method used in forecasting. Uh, so in science, time series is actually very popular in most fields. Like time series is a series of data point indexed in time order. Most commonly, the time series is a sequence taken as successive equal space point in time, and you can find this time series in the stock market, our subject today. This is actually alphabet chart for last day. You can see how the price of the stock market changes with the time when you have by hour. Uh, because the paper talk about limit order book data, very simple. When you give your agent in the stock market sell limit and buy limit, actually he can sell until he achieve the limit, he stop selling, and he can buy until achieve the buy limit to stop limit. So they have record for this data in the agent, and this help us to forecasting how the price of the share go up or down, and help to take the decision. Time series not only in the stock market, but actually in financial sector. In any organization, you can follow the advertising time series and see what the sales as a time series effect of the advertising. So uh, uh, I see it's about 100 years now. Scientific community try to use the data of time series to forecasting precisely the predicted value of the time series. For example, they have many way. Most of it is statistical way. We have simple moving average. We have exponential smoothing method. We have auto-regressive integrated moving average. And with the advancement of machine learning, we have now artificial neural network. The problem in this statistical way, you have to actually make a lot of calculation to separate the trend, seasoning, the effect of the season, and a lot of times is take a lot of time to make this forecasting if you have big data. So it's not easy one. Uh, what's the problem we have? What's the challenge in time series? Because time series is not like any data. It have a complex non-linear relation because we have many factors affecting the time series. This is actually one of my work is time series in energy forecasting. This is one of example. Here we have the load of the energy and the time, and you see very complex nonlinear behavior. You have many factors affecting the time series. The most important factors that affect the complexity of time series is the complex human activity, because most of time series, like the energy consumption of a stock market, related to human behavior. Also, weather condition for some time series, like in energy forecasting, special event or holidays, daily or weekly cycles effect. If you look back, you have actually certain pattern, and the weekend is different from the normal day or even holiday. This actually makes the forecasting of time series is very complex. A lot of people try to enhance the forecasting to achieve very good accuracy. And we know with the existence of machine learning algorithm, we can, if we have big data, we can using machine learning algorithm to have more accuracy system. So big data will lead for higher accuracy forecasting system for time series, but we have a lot of challenges. These challenges come from the nature of time series, and in the paper here, they propose architect to overcome of many problem now exist when they try to use deep learning and big data in forecasting of time series. The main concept they use here actually it comes from computer vision, very successful concept called bag of features. Bag of feature in computer vision have many steps. First, you have the object. Here, image in our case is actually time series itself, and now you can extract several feature vector for extracted from the object. For example, here in the picture, as you see, the first picture, we can extract some feature. This we call it feature extraction stage. This actually form what we call it the extraction space. The second stage, a set of representative vector, this vector from feature, we can learn and you learn it in our algorithm and use it to quantize it, the vector, the extracted feature vector from what we call it code book. And then the last step, using this to find histogram or representation with the quantized feature vector aggregated to extract a constant length representation of the object. Here we use a time series, so it will be temporally behavior. So it you can okay. Here be,
Yeah, what does dictionary learning means?
oh, okay. No, dictionary learning because in the stage of extracting the feature, we forming what we call it a feature space, and then we forming from this vector some vector from this feature. As you see, this vector become what we call it code word collection. All collection of this uh, code word from all the object. We call that dictionary. We call it code book. So
What does this really
this-
learn?
here you learn it all the feature you extract as identified like it's unique, and you make a space from it. I don't know if you know, for example, uh, uh, like in the quantum mechanics in Hilbert space, if you have like wave function and you wanted to identify this wave function, you try to find what we call it the base function. Here, what we can try to do, extract some feature. It's actually unique. Make from all the unique feature from all the box from all object a space. This space we use it after that to as a quantizer to make histogram for the picture, the object. All the collection of all these extracted feature as a code word, we can use it, what we call it, code book. We use it to quantize it, the feature object. Okay.
What does this histogram correspond to again? What does the histogram in this correspond to? And like,
After you, the last step, you take the object and take the code word and make see how the contribution histogram, how many like belong to this picture. Okay, if you see this feature, it's here, so it take higher value.
just like the score that
The score, yes.
Maybe kind of the importance of the contribution to the
Exactly.
picture.
Yes.
And
This actually give you a unique representation for the object through this histogram. Even this object is different in length or different in shape. So you get to some ways that AV to standard to identify unique identification for the object. Okay.
And in computer vision, we have like images like those you have there, and then you map them in like it's more like the idea of bag of words, like
Yeah.
giving
Actually,
them.
this is the same. This is what actually comes from bag of war.
Yeah.
But
And later we're gonna have like a few waveforms that they also gonna represent specific features, right?
yeah.
For time series.
Yeah, exactly. Here in time series, we actually we have the time series behavior. We begin to use some of its feature. There is many way to extract this feature. The simplest way actually to take the value of the feature as in the time step as this feature extracted. Okay. This is actually coming from successful application of bag of feature in computer vision. And in the computer vision, usually the images is very complex data. So using this way, it make the learning of the uniqueness of the features in the image is make it is easy and precise. Okay. When actually many authors many begin to introduce to get this idea from computer vision, try to apply to time series, but there is a limitation. The distribution of input feature is not stationary. In time series, we have a lot of nonlinearity. In the model, when they connect the big feature with neural layers, they have difficulty in tuning the hyperparameter. We'll see now one of the reasons in the model is used previously, and normalization of this old model have a lot of instability during the training. So the author tried to solve all these limitations and try to integrate deep learning with big of feature for time series to get a very accurate model. So what they try to overcome this limitation, they employing new novel additive scaling mechanism that replace the classical Gaussian-based density estimation of the kernel. Okay, this actually is a proposed uh, architect. We have time series here, and then pre-process. We take input feature vector. As I said, the simplest way takes the value of the feature in the time step as this input vector feature. Then we have neural feature extraction, which using the weight of the neural network to transform this feature vector to a new form. And then we have the proposed uh, uh, page of feature logistic one connected to the layer as actually takes this feature vector and have fine grained it to this feature, and then take that to the fully connected layer to using deep learning to learn from the time series behavior. Okay.
Yeah. Sorry, could you please go over the feature vectors? What are they again? What the input feature vector?
Feature vector here, input feature vector.
Yeah, what kind of data goes into that? Like, if you have a time series.
The file is like every time series when you have feature, you have many feature value with the timestamp. So you can the simplest way to take this as a feature, every timestamp value as a vector as a feature. But there is actually many people try to have more enhanced way to extract the feature from the time series. But this
They usually for forecasting they introduce lag. Like, you look back, like 5 step or 7 step or whatever it is, and then make that a vector. Is this the same concept here or it's different?
no, here he tried to learn the first all the like the trend inside the time series. So here, as he said in the paper, he used only the timestamp value as the first primary as a feature of the time series in this. Here we don't know, we don't use it for somehow forecasting the value, but we will take in the end when we run the experiment, we run to have classification it will be up or down the value of the stock market. So somehow is not forecasting next time steps.
Okay. Is this univariate or multivariate um, input data? Like, do we only have the timestamp value for the target vector, or no, we have other features too?
He said it's actually feature data. I think multi-value is not single value. It's not only the value and the timestamp. He have many feature with actually the data.
So, so for example, if we predict several stock price tomorrow, should we use the stock price today, or they just use the features value for tomorrow?
So he used the historical data to have like classifying for tomorrow what is will the movement of the share. It will be up or down, or it is not the same level.
So during the feature extraction stage, what it does is you have a neural network that extracts like certain features at each time step. So you could maybe calculate the first difference or like the second derivative of what the time series is doing. So each of those little boxes in the feature extraction stage will like look at one particular aspect of what the time series is doing at that time, and then you end up with a bunch of different features that way.
So is that like CNN or something?
Yeah, you can use a CNN or you can use a RNN.
But that's the next step, right? That's the neural feature extraction. So I think the question is input feature vectors. What are those? I think you were talking about trends. Are they just trend seasonalities? What I think the question is what is X IJ?
I said if you have like many feature and you have timestamp, you have vector.
Yeah.
Okay, he talked about the method when we need a leg to have multi-step to forecasting. Here, no, we actually trade it as actually as when we see in the picture. We take some component from the time series, and then we try to make a histogram for the behavior of the time series, and then he actually here have some inside the page of feature. He have long-term behavior, short-term behavior, and medium-term behavior, and then he have actually a vector represents all the time series. And something is different from the way. So he the input feature. He said the simple way take just the vector feature with the timestamp. But he said many other people proposed more sophisticated way, but need expert in the field of the subject of time series to see what's the features they have to choose to extract from the time series. But the simplest way, he choose just the feature with the timestamp.
Timestamp of what exactly?
The stock here, the stock is this the experiment the book limit order book data.
So the price.
The price with the sell limit, buy limit, some all historical.
I actually, go ahead.
Sorry, excuse me. So, if I want to clarify my understanding. So, imagine that you have a car, and this car you have like different motion detectors. So each of them like input feature vectors, right? And then you are collecting these input feature vectors on timestamps. So you have it in a time series, right? So in the pre-processing part, then you go to xij. So you have multiple, for example, acceleration, velocity. Each of them would be like the input feature vectors. Is that correct? And then you go there to neural feature extraction, right? Will you elaborate on that later, or what is this neural feature extraction from?
In general, will you go through these steps in the
Oh,
future?
okay. Actually, okay.
Are you gonna? I'm
We
asking.
will go to the step
Then-
through the theory.
If you're just gonna go
Because
through
actually,
that,
as we said, they already published many models before this model that don't integrate with deep learning because a lot of difficulties, and they propose this model in the theory. They see what is the problem in the old algorithm. Okay. 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 Um, So this is actually the architect of the time series they used, the input layer, the convolution layer, page of feature layer, and then fully connected and fully connected. Here the
Last
okay,
slide.
okay.
The convolution layer is a feature is a new feature transformation over there.
Here, yes, neural feature
Yeah,
extraction.
Just make sure I have that correct.
I actually like don't get it. Like, what is that layer, TLO and BOS layer? What it does?
This is actually the layer consists of logistic function, which it takes the feature and the actually here with details you see
Yeah,
what
alright,
you
yeah.
see. Okay, to understand. Okay, we have here the model or of the algorithm working. We have xi is time series collection of n time series. We have the time series every x1 to xn. The G feature vector extracted from the XI time series is denoted by XIG. As you see, we have feature in the time series. It's not just the value and the timestamp. And where Ni is the length of the I, this is the length of the time series. Now, when we go, we said the simplest way, we take just this feature as our feature vector. We don't have any processor, it's just the simple one. And then we go to neural feature extraction. Neural feature extraction actually processing the feature and produce transformed higher level feature. The item series here now represented with this transformed time uh, uh, transformed high level feature by neural network. And then we have the V, which is a code word coming from the time series. The simplest way actually to form this time series, you put the time series uh, into using k-mean algorithm to find what is the feature inside the mean feature inside the all the series, and from that we have the code word, and we have what we call collection of these code words we call dictionary. Okay. Uh, the problem that combining this simple way of extracting the code work by k-means with deep learning neural network have many problem that actually you have the feature distribution is not stationary, and every time you train next step you need to get a new book from feature because the not stationary of the time series.
I have a question.
Okay.
So how do you make sure like NK is enough for code words in your dictionary? Like, is there like any metrics? Like,
Here in the case they have actually bidding some they check that there is a consistent of all the lenses, and bidding a lot of like checking algorithm that if you don't have enough to extract enough vector to be covered in K.
Here you're just trying to embed the input feature into a constant length of features.
Exactly.
Which is the same as word embedding, as long as you can choose the length of the features by yourself, I think.
Yes.
Online live chat. One of them was, how many dimensions do you have for one timestamp? Can you just answer that?
They said the D here depend on the feature extracted in the time series. So the D is depend on the number of dimension in the time series.
Okay. Cool. And then another question, will they also use the name of the financial instrument as an input feature?
Actually, I didn't know exactly all the feature type, like what they like the name of, or they just said we used the data set from 5 Finnish companies in the stock of in Finnish market.
So it's possible, but also possibly not.
Oh yeah, I don't know exactly.
Very relevant to that question. Is that possible to like use features, like the name of the security, and then run convolutional neural net on it?
Okay, the name you can hot coding to code it as a numerical value and use it. What's the problem?
The problem is it doesn't have any weights. Like you cannot, like if you code it as one and then the other one is 12, and then you normalize all, it means that 12 has higher weight, maybe.
No, it's like binary 0 1s.
Oh,
No, but for convolutional, I'm not sure if you need to like do like pattern coding and stuff like that.
there's actually, as I think, the almost category have to be coded to vector, like, and you can actually use it in training of deep learning models.
I think his question is how do you handle the category feature versus.
Let us assume if it's categorical, they're gonna use one hot algorithm. Let's just assume that, because otherwise they don't know their stats.
Okay. So we wanted actually to have the histogram that describes the time series. Okay.
Yeah. My understanding was that you have like used this CNNs to embed the features like with definite window size, right? To a fixed size embedding matrix, right? And then how was this k-means used? Because right now you have different embeddings and they're corresponding to different, for example, long-term, short-term, and medium-term sort of embedding. So you just use k-means over all of them? I mean, like, what was the k-means used exactly for?
K value, K mean.
K-means
Actually, the K mean here was used to initiate the code word. The code word here. This is actually the feature we first make our dictionary. Like we passing the time series to this key mean and extract the feature, the mean features, the behavior. For example, the trend inside the time series, and make from it blocks. And this block become like units. You can use it to measure quantizing the time series.
what were the tasks exactly?
What is the input of the k-means? Like,
So
what
the
is
series time series itself.
Yeah, I know, but the time series, right now for me, the first step before even pre-processing, the data itself, the input data is like vague for me. I have no idea, is it like D dimension vector input, or is it just the stock market price, or is it?
We said it's a feature and have dimension D. They didn't say exactly what is the D number, but this is the feature, and they use the timestamp with a feature as one input.
I think they're looking correct me if I'm wrong, but I think they're discretizing the waveform by sampling at different timestamps. So there you have now your discrete feature set, and then k-means they use it on top of them at some point, so that they don't have infinite sort of code words, but a few, and then I believe you use your feature vectors to represent each of those code words, so each of those clusters. So that's the way they're going to their
So you
feature.
have the embedding, and then you do clustering on top of that.
So you don't have embeddings. You just have some discrete representation of your continuous waveforms, right? So you have those, but that's infinite, right? You could go.
What is infinite exactly?
So I mean,
It's not infinite.
it's
Stock
very
market is a
it's
minute.
very volatile,
Let's say
right?
minutes.
Right. It's well, you have a
Resolution
set.
is-
You have a set, right? But it's volatile, right?
Yeah.
You want to create code words so that there are a few features as opposed to continuous values,
Okay.
right?
You want to discretize the whole, for example, the
So you
diagram.
discretize using sampling by timestamps.
Okay.
Then you have discretized them, but they are still the values are volatile.
Right.
Now you want smaller set of features, so you cluster. And for each cluster, you call them code word, and then for each code word, you have one representation.
So after you have good word, actually what we try to construct for the time series is a histogram, which will identify the time series and be used in our classification of the what happened. They actually said to have this time series, the old style, the people was using kernel density estimation, was using actually Gaussian. So this is a probability distribution to estimate your transformed vector feature to this one. So we have this actually relationship where k is the kernel and SIK is the time series specific parameter. Uh, you can actually estimate the SI using maximum likelihood estimator using this equation, and they actually showing that actually SIK can be driven from this relationship. And here, as we see, the UIGK depend mainly on the kernel of the used in the as the page of feature. The old day actually, or the other paper, previous paper, or author was actually proposed that the membership using normalized using Gaussian kernel, and as you see kernel here, the Gaussian one need to have the width of the kernel to and need also to have uh, the feature and the code word Euclidean distance square, the norm of this one. This one actually was the people, the author believes there was a reason behind the difficulty to apply deep learning or the slow of the previous models. They believe their limitation come from using not easy to actually to bot will behave to use the to put the weights because you have to actually try to find the best value. To overcome this limitation, they propose replacing the kernel of a Gaussian with a sigmoid function, and this is actually the main contribution in the paper here, removing the kernel from Gaussian to sigmoid. This is now, yes.
Can you go into the last slide?
Okay.
Because I think here this is just basically a Gaussian kernel. So you claim that it's a little bit hard to select the sigma here, but I think this is just sigma here, just kind of hyperparameter. You can just like RBF kernel, just turn it to with several.
He said the performance. They said in what they when they ran the experiment in the other model, it was difficult to optimize to find the best one, especially with the time series. And one of the reasons also that you have the norm here square. This norm make it the transition through the training is difficult to, and actually this is one of the things we'll see here without here without not scaling and without the find the training. 1 minute here. Okay.
What they're trying to do is like eliminate the necessity of manually tuning it. They want to
Okay.
use a function that like you don't have to tune at all.
Yeah. Okay.
And also because they wanted to integrate with deep learning to use the benefit of deep learning automatic uh, training of the data. So this is actually with when you integrate with deep learning, you have a problem because you have the modulus here. So they actually remove these modulus and use sigmoid function. Sigmoid don't have this the modulus of or the norm, and this actually makes the flow inside the feature to the deep learning is more simple. Uh, so as we see here,
Why was this kernel used again? Sorry, I couldn't catch on. Why was this kernel used exactly? I mean, why did you
this
use?
is actually to calculate the probability of estimation of the feature to this uh, 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 time series. Yes, you have code, but you have to describe the histogram of the time series. So you want to this is the element of the histogram. You want the probability. If you remember, when we talk here about this, actually give here.
I think here is trying to
Okay, when we
use.
have talk about that, we said here we'll give you how like probability it belong to this one.
Like a similarity.
Similarity.
Between each like or the distance from what you have between each archetypal code word.
So kernel is like the distance between these different features.
Feature with the code word.
With what?
With the code word.
Good word.
Code words.
Code.
It's more like projection to the new subspaces.
Yeah.
You don't say which code word does it belong to.
Yeah.
Kind of regression here.
So your code words are your new basis.
Yeah.
So you have this new embeddings, and now you want to take the distance between them by the kernel to find out which one belong to which cluster. Is that the idea?
Okay. This is actually the way they use it, the Gaussian one, and the Gaussian when they use Gaussian gradient, it was depend on the normal, the distance gradient distance, and this actually was the reason it's difficult to integrate with deep learning, and this is why they proposed sigmoid one. After that, we actually, as we said, they have fine-grained the timber segmentation of the scheme. We have a short-term histogram and mid-term histogram and long-term histogram, and then connect this vector to describe the time series. Uh, they also add these two terms, CS and CU, initialized average number. This is actually to make what they call it adaptive scaling, allowing the network to automatically adjust the norm of the corresponding vector to allow the smooth flow of information. So they put this number, which allow to them to have Adobe adaptive scaling for the norm.
Last like not keep last how do you make the segmentation of the short, middle, and long?
I I think this depends on the length of uh, if you want to do short time series behavior, you look for short period. If you average about certain, like he has the standard short period, standard medium period, standard length of the high period, and then try to project the time series to this behavior.
I have thought this is okay. That's my
Yeah,
bad.
I believe these are like window lengths, right?
Yeah,
I have
windows, yes, time windows. So, and they did the experiment here, the confusion layer. They try to see the effect of additive scaling. Here, this without this additive scaling, without the scaling. With additive scaling, this is the gradient Fibonacci norm. We see how it actually the here change is very small, here the change is high. The acceleration in the learning curve when they add this one. So they actually make this proposed architect, and they uh, get big data from 5 Finnish stock market, and they begin to train the system, and then compare the result with previous models or alternative approach that actually use most of it also big of feature, and to see how they propose it architect to perform compared to the other architect. So
There's one more question from online. Going back to the code words, how often are the code words updated?
here in deep learning, in this model, they don't actually update it because they consider it is the training process of the deep learning, and this is why they said they don't to integrate the deep learning inside the process. They put it as a parameter of the training. The neural network adopted or learned it from the time series.
Okay, so
So is it the case that the parameters that we're clustering are accessible to the neural network?
Yeah.
So given the loss and derivative of the loss, you change the parameters of your k-means?
No, they don't. As I here, they said the key means you can set as a generalization, but after that, it become part from the training of the deep learning neural network. It's like internal with the parameter of the weight of the, but they didn't specify that actually they use k-mean or something like that, and said this is the advantage of their way. You don't actually need to update the the code word.
So you don't update them.
Yeah.
So another maybe quick question. If you go to your last slide before your break slide, so right before your break slide. Yes. So you seem to have your the scale of your SI. So I would assume your window and your sampling rate of your Xij accessible to the network. So your network is updating those parameters, and therefore you have a very big, like steep learning curve on the right, right?
Yes, right. And actually, they say that they just initiated with certain value, the average number of feature vector per object for CS and I think CU, and CS is initialized to NK. So the bot initialization, and then the neural network access updating. Okay.
This is just like a yes or no question, so it could be fast. You mentioned the code word before, but sometimes time series data is very, very volatile, as you mentioned before, right? And you only take, was it 144 input, which is very short. Is the code word there to prevent overfitting from your very volatile small data?
Okay. Okay. Again, the question.
So because data is obviously very, very volatile, right?
Yeah.
Especially in time series. So a lot of times you may overfit, especially with a loss statistical model, to your like let's say your 3 time series window, right? So to over or to get over the fact that I may overfit to that, is that what the code word is for? Does the sampling of the code word prevent overfitting?
Yes. But actually here, as I said, the way they produce the code word depend on the deep learning, and it's actually internal inside the, it's updated, like it's not some, the old model they use key mean, and they have fixed one, and then they use uh, the same key code word in their model. But here for deep learning, they said actually because the as you said, the instability, the time series, they put it as an internal parameter inside the deep learning.
Yeah, so one of the things that they added the logistic function part, I think also prevents overfitting because it constrains all your histogram between 0 and 1.
Yeah,
So
yeah.
that you don't have, normally if you just took the inner product with your code words, it would be unbound. So
Yeah.
it would like mess up your fitting there. So.
Just another clarification question. What filter did you use for the convolution? What size was the filter?
Okay, 1 minute, because I think the table here, size of the 256 filter. Current size was fine. Okay.
Let's thank the speaker.
to actually to evaluating the architect, they use big data. Five Finnish companies traded in Helsinki Exchange. They have the 10 highest and lower ask order prices were collected each time step, with data were collected over a period of 10 business day. And then they have uh, actually the number they have 144 dimension feature vector were extracted, and they run process the data through 10 times through the this is the result. They run this data 10 times, repeated this time through the architect to evaluate the matrices. Here is the average, the uncertainty, and then the comparing the result of their model here, the first and second, and here this is for targeting 10 uh, times, and then 15, 10 and 15 times step were predicted, and comparing that with alternative or competitive other algorithm. They use this matrix for measurement. Here, just a review for the matrix. It's come from confusion matrix. We know precision, recall, and F score, the harmonic mean of the precision and recall. And then they have, because using many data sets here, they have macro precision and the macro recall and the macro F score. Uh, and they're using Cohen-Kappa coefficient, which actually probability of agreement by chance, which calculated by this formula. This is the result. As they highlight here, their performance is much more better than the other uh, models, which gives them that their architect actually able to overcome the limitation of the previous model architect.
What is WMTR here?
WM this is actually model for multi-channel time series regression. Weighted multi-channel time series regression is a model used by another paper.
This kind of baseline model, is they using the input features or they using the code book feature, code word features?
As I understand, most of these model using big of feature model, but they not using the deep learning, or they have the, as we said before, was using the Gaussian kernel, and this is actually what is the new of the paper here. When they remove the Gaussian, put the sigmoid kernel, and make the additive scale. They
I'm talking about the features, what they are using to make this model. They're using the input features or the because in the proposed architecture we have built a dictionary learning over there. Did they using the dictionary features for the baseline or they using input features in the baseline?
Input feature.
Input feature. Okay, input feature. Okay. How about if they using the dictionary features here?
Um, but I think because somehow the input have more space, like the space is much higher dimension. You have a lot of possibilities in the training when you try to catch the behavior of the time series in the deep learning. Overall, as we see here, they said their model, they have two row, and one of it use convolution layer, and see that the performance of the convolution layer always precedes the other model, especially in 15 time step. For 10 time step, we here a macro recall for row is much higher in certain time step, 10 time steps. Overall, their model, their proposed architect performance better from other than the other models.
Excuse me. Something I'm not getting here is like as we increase the window size, like we go from 10 to 50, what we expect is like the models could be less accurate because like the predictions that we might have in 2 days, they would be more accurate than in 10 days, right?
Yeah.
But here, as we increasing the steps, we are getting more accurate models. Like this is like something I'm not getting yet.
Because I think this in convoluted, maybe in convoluted, there's a filter over there. The probably the maybe the how to say it, just maybe the days before the prediction days, and maybe the 2 days before the prediction days. That is kind of more important for the have more contribution for the.
So is that daily recorded or like hourly recorded? How is
This is 10
Daily?
day.
Um,
10 day.
I mean, I think for the first one they have like 10 predictions, but for the fourth,
10 days.
This is how they
First
basically
here's 10,
predict.
and then we can set if you have inside the time series trend or seasonal that have some windows larger than small. If you have the trend, take more time to catch this trend. You need more time to find the accurate prediction.
So you mean like probably the model is suitable for like not for like it's more like for medium like
No, it's here said we perform better in both these two, 10 or 50. The model was accurate better than the other model.
so like what we if we go like for like 100 predictions, you know, how do you what do you expect like do you think
As you said, I think it will be decreasing the accuracy, but maybe because the 15 or 10 somehow have something related to the periodicity or the trend inside the data.
So I think an interesting question would be, are they using the same model to predict 50 and 10?
Yeah.
Or using different models?
The same model.
So is it the case then that the model has been trained mostly to predict longer sort of sequences in the future?
maybe.
Is that the case? But I mean, to contradict myself, then it seems every model. I think to get back to your point, every model is almost performing better. If you look at the F scores, in general, the models are performing better when the sequence is longer, which is counterintuitive, like at least from the NLP perspective.
They're just trying to predict the category, and on a day level, like if you're only looking 10 days out, maybe there's more variance versus 50 days out. It really has gone into one of those bins a little bit more. Like it's predicting the trajectory more than anything else, and there's more variance in the first 10 versus in the 50.
And that was my another question also. A good point. So you talk about F scores, then you have categories. Those categories were they the clusters?
The categories, so what they're trying to predict is just up, down, or safe.
Okay.
So they're just predicting the direction of the stock movement, not the bank.
So like classification, not forecasting the value of
So 50 in the future and 10 in the future, do they have the same historical? Do they have the same history span, or? So that's about the future. You're
I
predicting.
think so.
Yeah.
Otherwise, because in maybe 50 days, this kind of data will be follow the same pattern as the historical. Probably maybe this kind of historical data maybe 1,000 days, something like that. They have the enough data to build this kind of model to capture this kind of pattern. But in maybe of 10 days, maybe they have maybe a portion of this kind of fluctuation patterns. This reason they cannot capture.
So I think then are they using different histories for two different experiments, or the history is the same?
I think they said we collect the same history and then the direction, the same data they predict for 10 and then for 50 times 10.
But to be honest, I'm still not getting it. Why?
You're not convinced.
Actually, as you said, because you don't actually forecasting value, you actually up or down, or so the total behavior, like the average for longer period, for sure more.
Would be less accurate.
Okay.
Yeah.
So another thing then, when you're predicting 50 in the future, Are you predicting all of them at the same time?
Yes.
Or you're predicting
Yeah,
one
at the same time.
one at a time?
They're
No, at the same
jumping
time.
straight to, they're just saying predict 50 time steps,
Yeah.
they're not predicting anything in between.
Then you would have used,
Yeah.
that was okay.
Yeah. So I think the reason, like, maybe in my mind, one of the reasons that it's more accurate for 50 is that because they're just predicting direction, over 50, there's more time for like the trends to actually start pushing. So
Sure.
like the distance it moves is farther. Close
Sure.
in, you have
Yeah.
like a lot of random walk. So just trying to predict a direction is hard, even though you know like it's going to be roughly in this area. And
Sure.
50,
Yeah,
it could be
you're
like-
saying it could be more noisy as mentioned there.
Yeah.
Yeah.
It's,
Okay. Uh, the most I think I like in this paper is using successful tool in computer vision and actually employ that in time series forecasting. If you wanted to have creative solution for any problem in your domain, a lot of time you have to look outside your domain to see what's successful in other different and borrow this idea to help you to actually attack your problem. If you close-minded to in your field, you can't actually successfully create more creative solution for the problem. This is the advantage of this beige model of feature model with they able to hear integrated with the capacity of deep learning model, and this leading to a powerful model for time series analysis. Their formulation for logistic formulation of the new way they choose, using logistic formulation of Bischoff model was actually the adaptive scaling mechanism allows them to direct training the architect end-to-end fashion without a lot of fine tuning or able to play in the hyperparameter. And this one I think it's advantage, especially if you have big data time series and you actually can use very this tool or this architect to be benefit from the big data of time series. Thank you. Okay. Come for discussion. Yes.
Okay, so
So you mentioned that some of your the most common kind of data like this is where there's even time between things. In my work, I deal with a lot of like transactional data, where we're more care about the individual. I'm wondering if you might be able to apply a similar technique, like a bag of words, to something where there could be weeks between transactions, or there could be hours. Do you think you could do the same kind of thing? Do you think it would work with this kind of model?
I think actually this is one of my next step in my research to something like this I can use in any time series model. If you have time series data, as you said, transaction with time stamp, and then you have the series behavior of the person. I see in energy consumption that human activity have this cycle. If weekend you have different pattern for your buying something than in normal days. In winter you have something you're buying not in the summer. So this trend is, and so I think it will work very good in something what you said time series. But I think this for single user or for the aggregated behavior of the user like.
Ryan, did you have points you wanted to share?
yeah, so something I want to like. Oh, you can keep it. So something I want to like. I was wondering about is how you would. So what they did here was classification, but I was wondering how you could. Well, you would have to change to do regression because a lot of the time you don't just want to know the direction of the change, but you want to like get an actual value. Like I know our prediction of electricity load, we want to get an actual value for the load. We don't just want to know if it's like higher or lower, right? So do you think this how about
I think with this configuration or architect, we need to have some component to ensure that actually that the prediction can be like regression, not. But in this form, it's more suitable for the direction of or classification of the. But to make it regression to the value every step, I think you need to add something here.
I think here you have the same architecture. Think about you have a dictionary as a words, back features as a code words. That is a vectors, and think that kind of stuff as words, and you can use that words to play with Rn over there, and use with using Rn to play with auto regressions, and you can use that kind of features as input, and put maybe kind of LSTM or other cells that play and just stack it on later, one step by another step. That is the auto operation.
You add LSTM here, but as I said, if you add, for example, LSTM is it may be help to have this regression because the LSTM can pick up the other like the change in small steps in the time series.
No, no, I mean, you have you agree that we can use these using the words to play with Rn. We can use Rn to play with auto regression.
Okay.
But here we have dictionaries that is vectors, which is the same vector as a word vector.
Yeah.
So you can input that vector into the
Rn.
Rns. Yeah. Yeah.
With
That's
different lights, maybe.
Yeah.
Okay. Yes. We will try because we have a lot of actually because I like this paper to open a lot of new trying in the research of time series. May be helpful to get more accurate models.
Yeah, I was so curious if you go back to the architecture. The architecture diagram. Yeah, I think there's a lot. I wonder if you could improve. So they just did 2 fully connected layers at the very end, like using the bag of words feature. So I was wondering if you could improve that somehow. I think like there's a lot to be extracted there.
I agree with you. This is why I said so. When we can make a lot of playing this, especially the deep learning layer, changing we can.
So, are they concatenating the last TLO and B, like bag of feature layer? Are they after that layer? Are they concatenating?
Yes.
The SIs.
Yes, they connect here.
They're concatenating.
Yeah,
Yes, I think so.
Okay. Oh my direction. As I said, actually, with my experience in physics, this is what the normal thing you do. Hilbert space, if you heard about it. If you have a system, you have a function describing the system, and actually you don't know the function exactly, so you try to bring a base function, orthogonal, it's like code word, and then you try to project the wave function or the system, and you can from that see the contribution from the base word to this function, and use that as interpretation for the function, and use it for calculating the system behavior. The idea that in normal geometry you have projection. You try if you have unit vector and you have any behavior as a vector, you try to find the projection, and from that you can actually use it to calculate anything related to this vector. Okay. Here. Okay.
Well, I have one question here.
Okay.
Like, as you know, like the time series might be very volatile.
Yeah.
So even like once we have a very huge peak somewhere, so do you think like that might be also considered as a word, in vocabulary?
I think yes, but
Yeah.
it's depend on the frequency in your time series, how many peak like that you have, because if it is not abnormal or outlier, but if it's the frequency of this one, you for sure it will be one of the good word in your.
Usually, what we do, like I personally cap both high and low my waveforms, just in case something is like something ridiculous is happening. And they had a pre-processing step, so I assume they would do that. But for the code words per se, because they're using k-means, it would a little bit normalize those as well. So if something even makes its way through, I would assume that the centroid of the k-means would bring it down to the center a little bit. Right?
But the thing is, sometimes people are looking for those peaks, you know. They're gonna
To
make
make a
money
lot of
out.
money.
Yeah, exactly. So if you just remove them, like it's you know.
Why? You could make it rich.
Yeah, actually,
Yeah, because basically traders wait for that peaks, you know, like
actually
only for those things.
the
So
the limit order is actually looking for that because you look if you have a certain value, you make the order. If you don't have, you actually don't uh, make.
especially in energy market, I've seen like in 1 hour we can make out of just 1 megawatt something like 1,000 bucks in 1 hour. So that's why like it's
Peaks are
worth it
important.
to wait, you know.
Yeah, actually, for like energy forecasting, like the locations of the peaks are very important.
Yeah.
Like you don't care too much about what it's doing normally, but if suddenly like it jumps up really high, you need tons of electricity. All of a sudden, then this is when you
Yeah.
have problems.
That's why.
It seems that they don't even like it's just a direction. So we're
Yeah.
far away really from. So even the values are the average, the moving average even is not under question,
Yeah.
right? But yeah, but
And they have to predict that like 2 days before, and that's the point. that's the funny thing
Yes.
about energy market.
Actually,
So.
So does anybody else have any comments or questions they want to add or ask?
Yeah, I basically the time series data that we have here, is it basically kind of batch through the process? It's not basically giving them like step by step.
no, it's batch. It's batch.
It's batch
Yeah,
altogether.
yeah. As I said, actually, the batch size here in the paper, in details, actually, they describe how they feed, how many batch.
It's like basically a data set
Yeah, yeah,
of all those
yeah.
things. Because there was a discussion of RNN, but RNN actually cannot be used in that fashion. So it could basically run one at a time. So you process one time step, and then after that you get back and do the next time step, and so on. So it doesn't work in that case. But so I don't know actually how feasible it is for real life application if you batch process things, because the applications, most of the applications are real time. So you have the information up to now,
But
and you want to
in,
predict.
in training, in training stage, you can use actually a batch because all like,
As long as actually this is very quick to process.
okay.
So I don't know how long it takes to process things. Because if it takes like 2 hours to predict the next 2 hours, then essentially it's useless to use that. You know, so you want to basically kind of takes less time to process that, and that's something that I wanted to ask, but I don't know how long does it take something like to train.
sorry, I'll let you answer.
No, okay. Because actually, as I understand, you can have batch training, and then when you predicting or forecasting, you just forecasting for the one next step or second step. So the training actually, this is actually the benefit of batch offline. You have big data, so you can actually see all the behavior. As long data you have, you can actually make the deep learning or the neural network more understanding the trend inside the series, and then you can use this training to just forecasting the first, second step or second step. So training process here.
That's the key. So if you pick actually a bigger portion to process, it takes more time and it's more accurate. But if you pick like less portion to process faster, but it's less accurate. And that's the thing. So it's kind of like batch processing has like this limitation as well.
I think here they use, as I understand, it's big data platform, cloud computation. In this time, in this case, the resources available for processing and training here is much higher than limited resource. And this allows to them to use, actually this is the benefit. If you have a big historical data, which allow to you to understand the trend, the behavior. You have to train most of your data, and then when you predict, you can choose just very one step or two step, depend on the last uh, data you have.
So out of curiosity now, do you know what is the common model that they use in financial sector, like for predicting like
For,
financial information trends?
I don't know exactly what's the trend, but for many time series application, LSTM was actually one of the big player because they able to understand or get the trend and the manner inside the data set. I used it in electric consumption, and it's give me very good accuracy to compare it to other model, the LSTM. Uh, yeah, for financial, actually, I didn't try before, so I don't know.
Can old people also still ask? So, like you asked for the new people to ask. Oh okay. So how many time steps do you look in the history to predict your batch?
Uh, I give you here. The paper said we have uh, 10 business day. Okay, 10 business day with 4.5 million limit order. 4.5 million limit order. Okay, this is the total number is actually was this is why actually, as I said, the benefit of big data, if because uh, this allow to you to get all the behavior inside the time series.
Sorry, are any other questions or comments?
So about your question about trying to do it in real time, I think one of the things they mentioned is that for the what is that, the neural feature extraction stage. So what they used here was CNNs, right? So then you need like a big history, but they said you can also use RNNs, recurrent networks, so that you can just do it one step at a time and like basically do feature extraction and
But then you would be much slower,
yeah.
right?
Yes.
Because they have to do per step. You can't parallelize it.
Yeah.
Another point is probably maybe the dictionary build can be separated with the
Yeah.
model training. You have maybe different set. You pre-process a set of the data and you use that kind of data to build a dictionary and using that dictionary to build in the model. At the meantime, you say pre-processing another kind of set of data to build using that kind of data to build another dictionary with embedding features different, just separated, and then you can keep feeding over there.
This is very good idea.
Okay, I think I'll end this section then. So let's thank our speaker and our facilitator.